What's up, everyone? Today I'm going to show off my custom GameCube controller, which is based off of the SmashBox configuration. My box here uses an Arduino that utilizes the NicoHood GameCube API. So this video is going to serve three purposes. First, it's going to explain some of the motivations behind this project and why I built the box. Second, it's going to explain some of the more technical details on how the controller functions. And third, it's going to go through what it's like to use the box as a player playing Melee at a high level. So stick around and hope you enjoy the video. Why did I make the box? The primary reason is that it's clearly ergonomically superior. On a traditional GameCube controller, your thumbs are doing almost all of the work. In competitive Melee, you can have bursts of 200 or 300 actions per minute. And in a tight battle, you can be tensing your muscles unintentionally. The SmashBox configuration puts your hand into a keyboard position, and that distributes the stress among more muscles and more fingers, which means less pain and more playing. And as a person who's had some hand pains in the past, I said, why don't I just give it a try and see if it helps? The second reason is the argument about input consistency. Now that you don't have the analog stick on the SmashBox, there's an element that's taken away where there's skill involved in putting your stick at the precise angle. So I wanted to see what the effects are as a player when you no longer have the analog stick. Now I'll go into some of the details on how the controller works. I'll segment this section into software and hardware. From a software perspective, there's an interesting protocol between the GameCube and the controller with a 24-bit start word and a 64-bit return data at a certain polling frequency. However, the cool thing is that we don't need to worry about that because the NicoHood GameCube API takes care of all of that under the hood. For those that don't know what an API is, the easiest example is Google Maps geocoding. Geocoding is basically taking a latitude and longitude and converting it to a street address. So Google might have some complex algorithms or unique databases, but as a user of the API, I would call a single function and Google takes care of the rest for me. So if I enter 96 Winthrop Street, it will spit out the correct latitude and longitude, and I don't have to deal with any of the under the hood stuff. Same thing goes here for the NicoHood GameCube API. I tell the API that the user pressed X, and then the API will properly send that input to the GameCube. This greatly simplifies the controller script. The script is basically broken down into three parts. The first part is assigning each button to an Arduino port. This is the input for each button. The second is instructing what happens when a button is pressed. So this is really important for the modifiers. And third, we're going to call the API to send the status of each button to the GameCube. The software is really flexible. I didn't have enough input ports on my Arduino, so what I did was assign a combination of buttons to be start instead of actually having a start button. SimpleControllers made a great guide on how to make a SmashBox, and I based my script off of theirs. So I'll post the link in the description. Alright, let's talk hardware. Let's start by looking at what's coming out of the GameCube. So the bottom line is the 3.3 volt logic supply. This basically supplies the level of voltage that the GameCube controller will use as the logic. So 3.3 will serve as 1 and grounded 0 will serve as 0. The next two lines are both ground and don't really play a very important role in the setup. The fourth line there is the bidirectional data line, and this is the most important line on the GameCube. This is where all the data is being sent back and forth between the Arduino in this case and the GameCube. And the top line there is the 5 volt rumble motor. So the 5 volts is typically used to power the rumble motor inside a GameCube controller, but in this case it's used to power the Arduino. Between the 3.3 volt logic supply and the data line, we can see a pull-up resistor. The purpose of this resistor is to keep the data line at logic 1 at all times, and when sending a 0 will ground the data line. The purpose of this is so that floating voltages can't cause the GameCube to accidentally read a 1 when it's not there. So you keep it at 1 at all times and ground it when we want to send a 0. The next circuit element is the logic converter. This is needed because the GameCube reads a logic 1 as 3.3 volts, and the Arduino reads logic 1 as 5 volts. The logic converter basically does exactly what its name is. It converts the logic. So when the Arduino sends data at 5 volts, it gets converted into 3.3 volts so that the GameCube can read it, and vice versa. I've also drawn in an example button connected to an arbitrary pin. The button also acts as a pull-up resistor with voltage constantly running through it. When you press the button, the voltage is grounded and the Arduino reads it as an input. Let's take a look inside the box. Each colored wire is connected to a button, and there are 19 buttons total. All the colored wires plug back into the Arduino, which is in the center. On the back wall there's a breadboard. You can see the GameCube wires taped up to the back of the cardboard wall. This is where the Arduino and the GameCube wire interface. It's also where the logic converter is mounted. So, this is the flow of sending inputs to the GameCube. The GameCube first polls the controller. The Arduino will then read the status of every button that's plugged in. It then converts the status of each button into GameCube inputs, and then it will send that information out the data line through the logic converter and into the GameCube. If you're interested in making your own SmashBox, I highly recommend checking out SimpleControllers' guide. Each button is $2, and the wiring altogether cost me about $20, and a logic converter was cheap. It was $3 or $5. I already own the Arduino, so I didn't have to pay for one, which is great. And I also mounted mine in a cardboard box, but I'll eventually like to mount it in wood. If you plan on making your own, this could be anywhere between $100 and $120 if you don't have any of the components. Some of the skills that are required for this project. Soldering is the first and foremost. I had to solder pins to a logic converter and solder leads to the GameCube wires and to the quick connect that connects to the buttons. I didn't have much soldering experience beforehand. I just watched some videos and practiced for a bit, and eventually you get the hang of it. Experience with Arduino and C++ is also great. Even if you don't have any coding experience, I recommend checking out the script and seeing what you can figure out, because it's not a very difficult program. Other than that, maybe some woodworking skills if you plan to mount in a wood box instead of cardboard. What really makes the SmashBox unique is the left side of the controller. The red buttons represent the analog cardinal directions, and underneath are the blue buttons, which are the modifiers. They're labeled Y1, Y2, X1, and X2. The basic idea is that when holding a modifier, the analog buttons only do a fraction of their full press. So when holding down Y1 and pressing up or down, which is the Y-axis, maybe you'll get 25% of the full press. When holding Y2, maybe 50%. And when holding Y1 and Y2 together, you get Y3, which is maybe 75% of a full press. These aren't the exact values, but the concept is still the same. And same goes for the X-axis and the X modifiers. The digital buttons on the SmashBox allow for greater consistency over the standard GameCube controller. The two biggest techniques I found a difference in were dash dancing and shield dropping. When dash dancing on a standard GameCube controller, the stick has to travel from full left to full right. The player also has to ensure that they're inputting a smash input every time. The digital inputs make you feel like you have greater control over your dash dance, because now you don't have to control an analog stick, you can just simply press buttons. As for shield dropping, you'll never miss this input again. Using a combination of shield, Y2 modifier, and down, you will always get a shield drop. Even at the highest level of melee, no one has a 100% shield drop rate. With this controller, it's possible. One of the biggest difficulties I face is DI. Typically, on reaction, I use one of the 4 cardinal directions to DI. I'm yet to implement the modifiers when DIing. What often happens to me is I'll get hit during my dash dance and be holding directly away and die at a very early percent. The SmashBox doesn't make you better at the game. Your old bad habits will still stick with you. However, you do get a chance to relearn the game, which is a great experience. Whether you plan on using a SmashBox or not, I highly recommend everyone try one out so that they can understand the limitations of their opponent. Hope you enjoyed the video, and have a good one.